Okay, so we're gonna figure out what elements make up this molecule right here. All we need to do is interpret the formula. What's one of the elements that you guys see inside of this formula? What's one element that's in here? Okay, we got oxygen right here. Good. Okay, so oxygen is in the parentheses. Shh. Okay, so how many oxygens are inside of the parentheses? 4, yeah. But if there's a 3 on the outside, what do you have to do with the number outside the parentheses? Yeah, multiply. So if I multiply 4 times 3, how many total oxygens do I have? 12, good. So we have 12 oxygens. Okay, so we have 12 oxygens. Hey, Jordan, I know that she's pretty, but I'm gonna need you to look at me, okay? It's because you keep looking back. Hey, that's my only assumption. Okay, so you're saying she looks like Candy? Hey, Jaylene, give him a shot. Give him a shot. Yeah, give him a shot. He's a good guy, and I support it. I know. Well, I mean, if he had a condition where he only had to look back, I'd understand, but I'm assuming he can look straight. Oh, you sure? Oh, okay. Not bad. I'm more interested in your love life, though. I'm trying to help a brother out. I want to help you, dude, because Jordan's a good guy. You are. I agree with that. Baby? Oh, beautiful? Beautiful. Big? You are tall. You are very tall. You keep telling me how much taller you are than me. I get it, okay? All right, anyway, so we have 12 oxygens. What's another element that you guys see in here? Yeah, we got aluminum. How many aluminums do we have? Yeah, 2. The number behind it is 2. So we're going to have 2 aluminum. All right, and then last but not least, what's the last element? Sulfur. And how many sulfurs? 4. Not 4. So there's 1 in the parentheses times 3, which is 3. Okay, so we have 3 sulfurs. All right, so hopefully that was pretty simple. If not, make sure you guys get practice with this because you guys won't be able to do today's concept if you're not comfortable counting up the elements, okay? Okay, so what we're going to be talking about today, we're going to be talking about something called, actually, I'll get to that in a sec. So let's do a little pop quiz, okay? So if you have blank, how many do you have? So if I have a dozen of something, how many do I have? Good. If I have a pair of something, how many do I have? And if I have a trio of something, 3. Yeah, west side, right? My bad. Hey, man. Yo, I grew up in the mean streets of Cypress, California with all the Asians and their Honda Civics and their Camrys. Anyway, so a dozen is 12, a pair is 2, a trio is 3. Now in chemistry, we're going to learn another way to count something, and we call it a mole. Okay, a mole of something. It's kind of weird. It's like that furry, ugly animal that lives in the ground. Okay, so the reason why we use a mole is because atoms, like we said, are super duper small, right? And so when we count atoms, we can't count them a dozen at a time, 100, or even 1,000 at a time. We have to count them a mole at a time. Okay, so if I have a mole of something, you have that many. 6.02 times 10 to the 23rd, or that. So I think that is, Mr. Edwards, you can correct me if I'm wrong, but this is 602 million trillion. Yeah, that's what exactly. I wish my bank account looked like that, but right? Anyway, so this is when you have a mole of something. Okay, so just to help you guys understand it a little bit better. Okay, so just to help you guys understand it a little better, if you have a dozen donuts, you have 12 donuts. If you have a mole of donuts, you have that many donuts. If you have a pair of shoes, you got 2 shoes. If you have a mole of shoes, you have that many shoots. It's just a way of counting, just like a dozen or a pair or whatnot. Okay, so this number right here, we call it Avogadro's number. I call it Avocado's number because it's easier to remember. But we use Avogadro's number to count atoms because atoms are so small. Okay, and the reason why this matters is because on the periodic table, if you guys take a look at the number on the very bottom, okay, we call this the molar mass. And that's going to be the mass of 1 mole of that element. Okay, so depending on the element, it's going to weigh a different amount. Okay, so if I have a mole of xenon, it's gonna weigh 131.293 grams. Okay, and the way that you would write this is 131.293 grams of xenon equals 1 mole of xenon. I think you guys can kind of see where this is gonna go. Okay, so when you have the number on the bottom is grams of that element equal to moles of that element. Yeah, write this down. This part right here you want that. You don't need to draw the picture, but you want to make sure you write down molar mass because that's going to be the concept for today. Okay. Okay, so we're finally talking about the number at the bottom of the periodic table. It's called the molar mass. It's how much 1 mole of that element weighs. So every element is going to weigh a little bit different depending on the molar mass. Okay. Any questions about that, or does that make sense? Make sense? Okay. Thanks. Fits all my stuff. It's because I had to change out into this ugly shirt. This disgusting shirt. I lost a bet. Hey, I know. This guy's been winning every single bet. It's so irritating. Whenever we don't bet, I win. And then I know, dude. This is a sign that I shouldn't gamble. Gambling's bad. Who dunked on me? He didn't dunk on me. Do I need to show a video of me dunking on him? Dude, his head is at my chest. Okay, I didn't say that, but hey, you know what, Jordan? Whatever you like to imagine, you do that. Okay, just don't say it out loud to me. Alrighty, guys. So let's move on to some practice problems. Okay, so we'll keep it easy in the beginning. I want you guys to find the molar mass of phosphorus. Okay, so go on your periodic table, look at phosphorus, and just jot it down on your paper. What is the molar mass of phosphorus? Okay, jot it down on your paper. See if you can write the unit of measurement. Okay, remember, we can never have a number by itself. We have to write the unit of measurement. Okay, and I just wrote the units of measurement up there, so see if you guys can do that. You'll see. Just jot it down on your paper. Stop looking at Jaylene and write it down on your paper. My bad. I'm just assuming now. Hey, do your best though. Winter formal's coming up. Hey, should we? We can sell snacks in this classroom. We could fundraise for your tickets and your formal proposal. Dude, I'm just trying to help y'all out. You know, my best friend married his high school sweetheart, and I want to support that. Okay. Nah, my wife's my first girlfriend. I didn't have a girlfriend until I was 22. It was tough, dude. Okay, in high school, it was so frustrating. Like, looking back, I'm happy, but at the time, this is so weird. Every time I liked a girl, she didn't like me. And when I stopped liking her, she starts liking me. Dude, that happened with like every single girl I liked in high school. It was so frustrating. I was like, can you just not like me? Why do we have to end on this note where it's like, bruh? No, I usually liked first. And then they saw how much of a stud I was, and then they started liking me. Because, you know, Mr. O is a catch. Extremely tall, extremely handsome. All right. And I'm extremely humble, dude. My name means humble. Anyway, phosphorus. So what is the molar mass of phosphorus? Yeah, 30.97. Okay, so we're gonna write down 30.97. Okay, but like I said, you need to write units of measurement. So what we can do, there's two ways you can write the units of measurement. The first way is the way I just showed you. You can either write grams of phosphorus equals 1 mole of phosphorus, or you can write it this way. I think this is a lot faster. 30.97 grams per mole. Okay, so either way is gonna work, but you have to give me the unit of measurement. You cannot just give me the number. Okay. All right, makes sense? You guys ready to make it a little bit more challenging? Okay. All right, well, too bad. Okay, so what we're gonna do is we're gonna find the molar mass of meth. And by meth, I mean methamphetamine, the drug, okay? So this is the guys, don't get too excited, okay? This is for educational purposes only. Okay, so molar mass of meth. This is the chemical formula for meth, okay? Guys, I know meth excites you, okay? It's a stimulant, that's what it does. But none of you guys are on meth. We're just looking at the formula, okay? Yeah, I might need to re-record this lecture, but anyway, yeah, but anyway, this is a chemical formula for meth. So what we're gonna do is we're gonna look at what meth is made out of. That way we can find the molar mass, okay? So this is the formula for meth. How many carbons are inside of meth? 10, okay? So we're gonna write that on our paper. There are 10 carbons. Okay, how many hydrogens are there? 15. And how many nitrogens are there? Okay, 1. Thank you. Okay, so that is what meth is made out of. So if I could figure out how much 10 carbons, 15 hydrogens, and 1 nitrogen weighs, and I put them together, I can find out the mass of meth. Okay, so this is what we're gonna do. We're gonna take a look at carbon on the periodic table. What's the molar mass of carbon according to the periodic table? Yeah, 12.01. So we're gonna write down 12.01. Okay, so carbon is 12.01, but there's 10 of them, right? So what we can do is we can just multiply 12.01 by 10. Okay. So if we punch that into our calculators, we're just gonna do 10 times 12.01, and that'll give us 120.1. Okay, so 120.1. So all of the carbons inside of meth are going to weigh 120.1 grams per mole, okay? Let's go to hydrogen next. What's the molar mass of hydrogen? Yeah, it's just the number on the bottom, 1.01. So what we're gonna do is we're just going to do 15 times 1.01 grams per mole. So we can punch that into our calculator. So 15 times 1.01, that'll give us 15.15. All right, and then nitrogen, what's the molar mass of nitrogen? Yeah, 14.01. We just go to the periodic table, look at nitrogen. The number on the bottom is 14.01. So it's going to be 14.01. So 1 times 14.01, and we don't need to do any math for that because it's just going to be the same number, 14.01. So that's how much the components of meth weigh. The carbons in there weigh 120.1, the hydrogen weighs 15.15, and nitrogen weighs 14.01. So all we need to do is add them together, and that is going to give us the molar mass of meth. So take 30 seconds. I want you guys to add that up and tell me, and write down on your paper, and we'll figure out how much 1 mole of meth weighs. Yo, don't snitch, dude. You shouldn't snitch people out like that. He's the only rat. He's snitching you out, dude. Yeah. You know what happens to snitches? All righty, guys, let's find the molar mass of meth. So we have 120.1 for the carbons. We have 15.15 for the hydrogens and 14.01 for nitrogen for a grand total of 149.26. But again, you have to write the units of measurement. So we have to write 149.26 grams per mole. And that is how much 1 mole of meth weighs. And if you guys know about anything about drug exchanges, 150 grams of meth is a lot of money. It is very, very expensive. Yeah, what's up, Zion? No, I'm not making any. What's up, Zion? Bye. Oh, anyway. Yeah, what's up, Jordan? Is it a question about this? Okay, we'll move on then. I'm trying to teach you the chemical formulas and how to find molar mass. And I know that drugs make you guys very excited and interested all of a sudden. Hey, but disclaimer to anybody watching this video, I do not endorse drugs. Drugs are bad, okay? Very bad. Moving on. Okay, find the molar mass of CuSO4. Okay, guys, I'll give you guys 2 minutes to do that. We'll go over and then we'll move on to one more type of problem and then I'll get you guys started. Okay, so find the molar mass of CuSO4. Sure. We did not do meth. We found the molar mass of meth. I need the video to be very clear. No, that's just the formula for meth. That doesn't teach you anything about making it. I'm not even going to touch it with the 10-foot stick how to make meth.
Why?
Because that's bad. I do not endorse drugs. I'm not supposed to teach you how to make drugs. One step. Okay, you finish. Educationally, yeah.
Do you have these substances, the ingredients?
I can neither confirm nor deny anything. All I'll say is I took organic chemistry and I was very good at it. But I'm gonna let you guys know, guys. I'm not gonna do anything that compromises me or sends me to jail. Because if you guys take a look at me, 150-pound Asian man is not gonna survive in jail. Okay. Well, yes, but yeah.
Make sure you're not tag your parents.
I'm just not gonna go to jail, guys. I've seen many big black men in movies. There's a lot of good-looking actors in a movie. I saw Space Jam. I saw Space Jam too. LeBron and MJ are like what, 6'6", 6'8"? Those are big black men, and I've seen them in a movie. I've seen Denzel. Denzel is ginormous, dude. What are you guys thinking about, weirdos? He asked me a question. I answered it. Yeah, I didn't say. I don't understand. Anyway, let's find the molar mass of CuSO4. Okay, guys? Okay, so the first element is copper. So what's the molar mass of copper, guys? Yeah, we have 63.55. It'd be funny if I did gallium after this conversation. Okay, so 63.55. Okay, so copper is 63.55. What about the molar mass of sulfur? Yeah, 32.07. Okay, so we're going to add that with 32.07. And then we have 4 oxygens. So if you do oxygen times 4, that's 16 times 4.
64.
Okay, 64, good. Okay, so all we need to do is add them up. So we're going to add them with 63.55, 32.07 plus 64. That'll give us a final answer of 159.62. So the molar mass of CuSO4 is 159.62. Oh, it's not a drug. It's just a salt. I'm not going to teach you guys about drugs, guys. I'll just let you guys know. Because it'll help you stay interested to do the problem. Yeah, we're about to do dimensional analysis with it. All right, guys, so I'm not gonna stop there. We're gonna add one more thing on, and the more you guys talk to me, the less time you have to do your assignment. So just to let you guys know. Okay. What we're gonna do now is we're gonna combine what we just learned with dimensional analysis. Okay, so in dimensional analysis, we said we always want to figure out what the given is, what you start off with, and what you want to end up with. Okay, so in this problem, it's asking us what is the mass of 0.25 moles of CaCl2. Now, the given is the starting number. What's the starting number in this problem? Yeah, 0.25, but we have to be specific. 0.25 moles of, yeah, CaCl2. Okay, so this whole thing is going to be our starting number. Okay, and in this problem, it's asking us to find what is the mass. If you ever see mass in chemistry, you are looking for grams. What's up? No, that's one of my ex-students. Yeah. Okay, so we're looking for grams. So if you guys ever see a problem asking for mass, it's asking for grams. Okay, just make sure you guys make that connection. Okay, so what we're gonna do is we're gonna start off with our number 0.25 moles of CaCl2. Okay, so we're gonna write that down. And same thing as before, we're gonna set up a fraction. And I wanna get rid of moles of CaCl2, so I'm gonna put that on the bottom. And since we're looking for grams, I'm going to put that on the top, okay? So far, so good? This is just regular dimensional analysis. Now, we need numbers for this fraction. So here's one thing I want you guys to memorize or jot down somewhere. If you ever see grams and moles on the same fraction, so if you ever see grams and moles on the same fraction, the numbers will come from the molar mass. Okay?
So it's
yeah, you're going to use the periodic table, exactly. So it doesn't matter if it's grams on top and moles on bottom, or moles on top and grams on bottom. Doesn't matter. If you see grams and moles on the same fraction, you're going to get the numbers from the molar mass, okay? Okay, so let's find the molar mass of CaCl2. What's the molar mass of just calcium? What's the molar mass of calcium? Yeah, 40.08. So calcium is going to have a molar mass of 40.08. Okay, but we also need to find the molar mass of chlorine. What's the molar mass of chlorine? Yeah, 35.45, but there's two of them, so we have to multiply it by 2. 35.45 times 2, that'll give you 70.9. Okay, so if I want to find the molar mass of CaCl2, I need to put them together. So I just add them, 70.9 plus 40.08, and that'll give me 110.98 grams per mole. And that is where you'll get the numbers for the molar mass. Okay, now you just need to be very careful where you put the numbers. Okay, so 110.98, is it next to grams or is it next to moles? It's next to grams, right? 110.98 grams. So you always put the molar mass next to the grams. Okay, so whatever number you add up from the periodic table, put it next to grams. And since there's no number next to moles, we're just going to put a 1 next to mole. Okay, and then from there, we can just do our math. The moles will cancel out. We have grams left over. Okay, remember the math. We multiply the numbers on the top and then we divide by the bottom. So all we need to do is 0.25 times 110.98, and that's going to give you 27.745 grams of CaCl2. Okay, make sure you guys get very good at doing this, because the next time that we meet, we'll be combining this with balancing and more dimensional analysis. You'll have 3-step fractions to do with this concept. 3 steps. Because I love you all so much. I do. Yes, a lot. Hey, I love and hate you all equally. Okay, any questions on any part of that problem? Yeah. Yeah, you're going to. Okay, you guys ready to try one more on your own?
No.
Too bad. Okay, so the last problem that we're gonna do is about my favorite chemical in the world. Okay, it's in my morning coffee. I think it's one of God's greatest gifts to mankind, and it's caffeine, not meth. Caffeine, C8H10N4O2. And a typical cup of coffee has about half a gram of caffeine. So I want you guys to calculate how many moles of caffeine are in my morning coffee. Okay, so I'm gonna give you guys 3 minutes to work with the person next to you, and you guys can calculate the moles of caffeine in my coffee. Okay, so go ahead and try that. Why y'all laughing? It's so weird. They just laugh at everything. Dude, caffeine is amazing. There is no other thing that's a stimulant with no side effects. Like meth messes you up. Huh? Around 17, 18? No. No, it does not. It doesn't, okay? It doesn't! I can't see. Well, that's not news, but no wonder why you're short. The disrespect in this classroom. Mr. Edwards, I need to like dunk on some of these kids. I need to assert my physical dominance, showing that I could jump higher. I know, it's just the same size, right? Carol, where are you? Where are you, Carol? She's so messed up, man. How's that racist? It's not. It's not. People just use that. If you use that term too much, it takes out all the power. So when something racist actually happens, people don't care. It's like the boy who cried wolf. Can't. Yeah. It's like when you guys call me short. It's not true. And so it loses its power. And it reinforces that I'm really tall. 8'8". No, it's not cap. Yeah. That's 8'8", right? That better be 8'8", Mr. Edwards. Or I'm gonna start sabotaging your labs. Alrighty, guys, I'll give you another minute to finish that up. I want you guys to find how many moles of caffeine are in my coffee. About to make another cup too. Steph, do you drink a lot of coffee?
No, I don't actually.
So what's your explanation?
I don't know. It just runs in the family.
Yeah, no, it's genetics. I told you, everybody in my extended family is short and fat. I come from a family of fat hobbits.
Bro.
It's true, dude. It's sad. It's sad when I'm the tallest.
I mean, at least you feel better about yourself.
No, I don't. I don't.
No?
No,
Because you know how people are usually taller than you? Like, how people think you're taller than them?
that's true.
Like,
I know, that's true. Everybody on this floor is taller than me, I think. All the other teachers, I mean. Yeah, I know. I get it, okay? Mr. Edwards, how tall are you? Must be nice, dude. No, so I thought you were taller, honestly. 6'2", dang. Wow. Imagine what I could do if I was 6'2". I would change the world. Honestly, I don't really care that much, except when I play sports. That's when I feel it the most. Alrighty, guys, let's do the calculations and we'll be all done. So let's start off by finding the molar mass. Okay, let's do the molar mass of caffeine. So what's the molar mass of just carbon?
Carbon is 12.01.
Yeah, carbon is 12.01. That's kind of close to 12, so I'm going to say it's 12. So 12 times 8, 96. Okay, what's the molar mass of hydrogen? 1. So 1 times 10 is 10. What's the molar mass of nitrogen? Yeah, 14 times 4. No, you're good. 14 times 4, which is 56. And then oxygen is going to be 16 times 2, which is 32. Okay. All right. Shh. Okay. Okay, so we're going to find the molar mass. Okay, we're going to add up the molar mass, 96 plus 10 plus 56 plus 32. That'll give me 194. So 1 mole of caffeine is 194 grams per mole. Okay, guys. So now we need to get our starting number. Our starting number is 0.5 grams. We're going to set up our fraction. What number should I put on the bottom? 194 grams or moles? Yeah, grams. So what number goes next to grams? Yeah, 194. And what number goes on the top? Yeah, moles. And then what number? 1. Good. So all we need to do is cancel out the grams. That way we have moles, and then we are almost done. Okay. We just start with 0.5. And then what should I do with the 194? Divide. Since it's on the bottom, we divide it. And so that will give me a final answer of 0.00258 moles. All right, and that's going to be it. Any questions? All righty, guys. So I'll give you guys the rest of the class period to work on that assignment. I highly recommend that you guys do it on a separate piece of paper because you need to show me how you added up the molar masses. So if you guys need, there's paper next to the door. And good luck on your assignment. Let me know if you guys have any questions or if you want to check your answers.